All right, welcome. Today, the Fundamental Theorem of Calculus, Part 2. All right, so the statement of the Fundamental Theorem of Calculus, Part 2, is that if you have a continuous function, little f, and a constant a, then if you let capital F of x be the integral from a up to x of f of t dt, then capital F is an antiderivative for little f. In other words, if I take the derivative of capital F, I get little f. Alternately, you can write it without the capital F at all. You could say d by dx of the integral from a to x of f of t dt is f of x. All right, so that's the fundamental theorem. In other words, derivatives and integrals sort of undo each other. All right, this is actually extremely useful because there are a lot of functions that we care a lot about who don't have antiderivatives in terms of any of the elementary functions like sine or cosine or x squared or x cubed, whatever. One of those is the function e to the minus x squared. Okay, that function is actually part of the normal distribution, that is the bell-shaped curve, so it's a very important function, but the antiderivative isn't one of the functions we already know. So here's an example. Write down an antiderivative for the function f of x equals e to the minus x squared. All right? Well, with the fundamental theorem of calculus, it's pretty easy. The answer is the function capital of f, defined as the integral from 0 up to x of e to the minus t squared dt. And we can't do anything more with it. That's the whole function. So computers, of course, can approximate integrals really well, so they can sketch this and calculate it to any precision we need. So this is actually the best you can do, at least as far as we are with calculus, for writing the antiderivative for that. Alternately, you could ask the problem like this. Evaluate d by dx of the integral from 0 to x of e to the minus t squared dt. And the answer is just, by the fundamental theorem, e to the minus x squared. So those are the same problem, essentially. You'll notice one thing here is that I always use dt's here on the inside. It's considered bad form to write things like this: the integral from 0 to x, e to the minus x squared dx. And that's because this x is very different than these x's. The underlined x's are just dummy variables. I could change them to any letter I want, t's or y's or u's. But this x is, as we said up here, it's actually the input for this function here. And so it gets confusing when you have x, the same letter, being used in different places for different meanings. So don't write it this way. Write it 0 to x, any other letter on the inside. T is a common one, but whatever makes you happy. All right, that's it for the Fundamental Theorem of Calculus, Part 2. See ya.